Welcome to Study Loop.
Welcome to problem number 10.8. This is chapter 10, Dynamics of Rotational Motion. So we are given a disk which has mass 40 kg and radius zero point 0.2 meter, and we have applied force 30 Newton tangentially. So when we apply this force tangentially, the disk will start rotating due to the torque applied to this force on this disk. And force is applied till this disk makes zero point 0.2 revolution. One revolution is equal to 2 pi. One revolution means that it makes a whole circle, which is equal to 2 pi. So zero point 0.2 revolution is equal to 1.25 radian. So this much is the theta angle covered by the disk when force is applied. After 1.25 radian or zero point 0.2 revolutions, there is no force, or we don't know the situation, but we are asked to find out the tangential velocity and acceleration of the resultant torque finally. So we have this formula here. There are some formulas here, so I will discuss one by one. So this is equals to moment of inertia of the disk, which is equals to mr square over 2. So disk is filled with the mass, so moment of inertia is mr square over 2. R is the radius of the disk. Now torque is equals to I alpha, which is equals to moment of inertia alpha. Alpha is the angular acceleration of the disk. So we have now equation of this angular velocity, which is equals to omega square equals to omega naught square plus 2 alpha theta minus theta naught. Theta naught is the initial angle and omega naught is the initial angular velocity. In this situation, we are given that the disk is at rest initially. So that means we have omega naught equals to 0, and we can take theta naught equals to 0, or you can say that this is equals to delta theta, or which is equals to theta minus theta naught. So we need to find out the angular velocity finally after having the torque due to this force, which we can find out using r cross f. R cross f is equals to rf sine theta. Theta is the angle between r and f measured anti-clockwise. So we are measuring the angle between r and f anti-clockwise. Now the angle is given that we have applied tangentially, so that means it has to create the torque equals to rf finally. So the acceleration is produced. We have tangential acceleration, and the second acceleration is radial acceleration. So tangential acceleration is towards the f, which has produced the acceleration or the angular acceleration, and the other acceleration is towards away of the radius, which is omega square r. So both are perpendicular to each other. So the magnitude equals to a tangent square plus a radian square and under root of them. So this gives us the resultant acceleration of the disk. So we will find out the tangential velocity first. So our first step is to find out torque. So torque is equals to Rf, which is equals to R capital F, which is equals to zero point 0.2 times 30. So this is equals to 6 Newton meter. So now using this equation we have here, so we have I alpha equals to 6 Newton meter over mr square over 2. So we have 7.50 radian per second square. So that's your angular acceleration. Now we know delta theta, so we can put this here. So to find out the angular velocity. So this is 0, so we have omega square equals to 2 alpha delta theta, which is equals to 2 times this value 7.5 times 1.25 radian. So this comes out to be some value and we take the under root of this one to find out the omega, which is under root of 2.2 into 7.5 times 1.25. So this comes out to be 4.342 radian per second. I have used the calculator to find out the value of this omega. Alright, now we're coming to this formula here to find out the tangential velocity. So tangential velocity is v r omega, which is equals to r omega. So this is equals to zero point 0.2 times 4.342 meter per second. So this gives us 0.868 meter per second. So after making 1.2 revolution, let's say the particle or the disk has moved this much angle. So tangential velocity at this point or tangential velocity of this sphere is equals to 0.868 meter per second. All right, so we have done part A. So this was part A. Now going to the part B, we have to find out the A, which is the resultant acceleration, this quantity. So we have first we need to find this quantity and then this quantity. We know everything. We know omega, we know alpha. So let's find out. So we have A tangential, which is equals to R alpha, which is equals to R alpha. We have zero point 0.2 times 7.5, which is equals to 1.5 meter per second square. Now finding out the A radial, which is equals to omega square R, which is omega square capital R, which is equals to 4.342 square times zero point 0.2. So this comes out to be 3.771 meter per second square. So your resultant acceleration is A tangent square plus A radian square. So this comes out to be 1.5 whole square, 3.771 whole square. So this comes out to be 4.06 meter per second square. So that's your answer for this question. We have found out the A and B part of this question. You can take a look at the first slide again and the second slide. So that's all for the question. Thank you for watching the video.